Hey guys, this is notes number 13. We're going to be focusing on another component of sketching. Okay, so remember, these next few lessons are all about knowing how to sketch a little bit better and a little bit more accurately. Okay, so this one is on end behavior. Go ahead and write down the FLT and press play whenever you're ready. So given a function, you're going to be able to identify the end behaviors of the graph using something called limit notation, okay? All right, so what is an end behavior and what is this so-called limit notation? So first, end behaviors, when you're looking at a graph, you're looking at how a graph behaves at the ends, okay? You're looking at how the graph behaves at the ends. And notice how I pluralize the ends, okay? So here we go. First off, I'm going to start off with a basic picture here. Go ahead and draw this out. We're going to draw the x and y axes, okay? I'll label it. Now, remember before, when you guys were using interval notation, we were focusing on just the x-axis. And I told you guys that if we go to the far left, so if I go to the far left, that's really negative infinity, okay? And that's not really a destination, it's a direction, okay? Because it keeps on going. And if you go to the far right, the x's get larger and goes all the way to infinity, okay? Now, similarly, let's try that again. Similarly, when you're on the y-axis, it's the same idea, okay? Now, think about what happens to the values as you go higher and higher up on the y-axis, right? So the higher and higher you go up, it gets larger and larger. So I'm just going to say when you go far up, it's going to go to positive infinity. And if you go far down, negative infinity, okay? Okay, so end behavior, let's go ahead and write this down. Let me use a different type of paper for you guys so you guys know exactly how to write this. Okay. Okay, so here's end behavior. Here it is in a nutshell, okay? First, I'm going to focus on how you guys should write it, okay? So in a single line, all right, you should write it like this. That's LIM. And notice how I left a little bit of space below it, okay? Because I'm leaving room for this right here. Notice how f of x is a lot larger. It takes up the whole space of the line. Okay. Go ahead and write it again, but now this is going to be negative infinity. Now, what all of this means, I'm going to explain to you guys. So just first know how to write it properly, okay? So f of x takes up a lot of space. The limit and what's below it is kind of scrunched up together, okay? So it's important that you guys do that because we understand that if I write 2x, that's not the same thing as this if the x was floating at the top, because then that would just be 2 to the x power. So how you guys write it is actually very important, okay? So this is how you guys read it now, okay? So suppose we were trying to read that very first line. You guys would say the limit. Okay, so I'll highlight it as we go so you know exactly how to read it. The limit of f of x as x approaches infinity is some number. Okay? So first, I want you guys to know how to read this, all right? So once again, it's the limit of f of x as x, that arrow is approaches, so as x approaches infinity is some number. Practice that a few times to yourself and then press play when you're ready, okay? It's the limit of f of x as x approaches infinity is yada yada. Okay, so the same thing down here, it would just be the limit of f of x as x approaches negative infinity is some number. Okay? So you know how to read it. What the heck does it mean, right? Okay. So basically it's this. What's the y value when x goes in that direction? Okay. So also known as what's the y value when x goes in that direction? Okay. The biggest component is this right here. We're looking for some type of y value, all right? In this case, this is our end behavior. That y value will represent our end behavior there. It's going to make a lot more sense, obviously, when I show you guys a problem, all right? So here we go. Let's go ahead and write in example 1 here. We'll write this out once. Find the end behavior. Okay, so let's say we had part A here, y equals x. Okay, so it's easy to find a limit when you have the graph in front of you. So what you want to do, just like in the last lesson, it's helpful when you guys have a sketch. Okay, now this here, it's okay if you don't know what it looks like, but you should know because it pops up so often, okay? Since this has a degree of 1, you know that it should be linear. So a line, okay? But actually this line is like our parent function. It's actually a line with a positive slope that intersects right at the origin. So you got something that looks like this. Okay? Okay, so here's what we do. We're going to write our limit notation, all right? So I'm going to write it over here. The limit of f of x. Now, f of x is the same thing as y, okay? The limit of f of x as x approaches infinity is, and then I'll leave a blank there, and the limit of f of x as x approaches negative infinity. So notice how I wrote it in the way that I said it. I'll do that one more time, okay? So check it out. The limit of f of x as x approaches negative infinity is. Okay? So I want you guys to imagine it like this, all right? Here, x is approaching infinity, all right? X is approaching infinity. So let's go back to what we had at the beginning. If x is approaching infinity, we're going to the far right, okay? So x can only go in 2 directions. X can only go either far left or far right. And while you're following the graph to the far left or the far right, you're studying the y value to see if it goes far up or far down. Okay, so look. If we're going to the far right, and I'll make a note right there so you can see it. If we're going to the far right, okay, what you're doing right now is you wouldn't draw this on your sketch. But just to give you a visual, you're pretty much standing right here, and you're going to walk until you go all the way to the right of that graph. And you notice that even though the orange graph stops right here, it's implied that the graph keeps going all the way up or down, right? It keeps going all the way up towards what? And I know I'm writing all over my notes, but I'm trying to exaggerate for a reason here. It's going to go all the way up to positive infinity. Now this is far up. Pretty simple concept. The notation is a little bit weird, but the concept is super easy. All right. So let me go ahead and erase all this now. Okay. So here in the second one, the limit of f of x as x approaches negative infinity. So remember, when x is approaching negative infinity, you're actually walking far left. So I'm going to have my little man up here, one-eyed little man, and he's actually going to walk left. And he noticed as he's walking on this orange graph to the left, he keeps walking downwards and downwards and downwards. And he notices that at the very end, even though there is no end, at the very end, it's looking like the graph is going far down. So when I'm going far left, I notice that the graph is going far down. Well, far down is the same thing as negative infinity. And that's it. All right? Now, technically, you don't need to write the whole far right, far left, far up, far down, but if it helps you, please do so, okay? Oftentimes, students mix up the y values for the x values, so just keep that in mind, okay? And that's it. Very simple. Let's do a couple more. Here's part B. Let's do our favorite curvy function, y equals x squared, okay? I want you guys to go ahead and do this on your own and then press play if you get stuck or if you're done, okay? Oh, keep in mind, so when they ask for end behavior, they're really asking for two limits here, okay? You got to see what happens when you go to the far right and when you go to the far left. That should be pluralized, so let me pluralize it. Behaviors. Okay, so part B, go ahead, and whenever you're ready. Okay, so just like the last one, it's nice if we have a sketch first. Okay, this one here, if you needed to use Desmos, but I really don't think you should. X squared is a very common function. It's just a parabola that is facing upwards, centered at the origin. So this is why it's important to sketch, okay? Because if you have an idea of what it looks like, you can get your answers a lot faster, okay? All right, we have a picture. Okay. So I'm going to say it out loud so that we practice, and you guys should too. The limit of f of x as x approaches infinity. The limit of f of x as x approaches negative infinity. So remember, when x is approaching infinity, you're going to the far right. So you got your little man here, and he's going to walk along the graph towards the far right. And we want to see what happens if he keeps going. Okay, so if you notice, if I go all the way to the end, even though there is no end, that parabola will get higher and higher and higher, and it will go all the way far up. So that's really positive infinity. Okay? That's it. It's all about you guys knowing how to analyze a graph. There's really not a lot of work to be shown here. Okay, so it's just testing you on how well you can interpret a graph. Okay, so here, when x is approaching negative infinity, we're going to the far left. So I'm going to put my little man over here so that he can walk left. And as he's walking towards the left all the way to the end, the graph behaves how, right? You notice that the graph still goes all the way up, so that's positive infinity. So notice how it's a little bit different from part A. Okay? Your end behaviors doesn't have to be one of each. They could actually be the same. Okay? So here's a question, you guys. Is it possible? Okay? Is it possible? And we're going to think backwards right now. For a limit of some function as x approaches infinity and the limit of f of x as x approaches negative infinity, is it possible for both of them to come out negative infinity? Okay? So it's not a super transparent question, you guys, okay? Really think about it. You got to think outside the box here because we're thinking backwards. What does this say about our graph, right? I want you guys to come up with a picture that'll give me these end behaviors. Okay, again, take your time. I would definitely pause this video to think about it and then come up with a picture that might give us this illustration. Okay, so there are a variety of answers. Okay, there's not just one right answer, but you should have something along the lines of both the ends of your graph should be pointing downwards. So negative infinity, the limit, implies that we're going far down for both. So that means that both arrows have to be pointing downwards. So the easiest one to think of is maybe the absolute value function that's reflected. Notice that when I walk towards the left, it goes all the way down, and when I walk towards the right, it goes all the way down as well. Okay? So this right here, if you guys remember, is just y equals the negative absolute value of x, because that is just your reflection across the x-axis, okay? So you're learning a couple of things at the same time. You're learning limit notation, how it behaves, but also you're revisiting how graphs are drawn, okay? When graphs are drawn in vertex form, which is pretty much the A, H, and the K, you guys should be able to sketch it, all right? Okay, so here's the last part. Sometimes you may get some weird ones like this. I'm going to give you the picture. Go ahead and draw this up. Okay. Now, this curve that I'm about to draw, try to draw it to the best of your ability, okay? Actually, let me draw that one more time. Okay. So I want you to go ahead and find, suppose that this right here is f of x. I want you guys to go ahead and find the limit of f of x as x approaches infinity. And I want you to find the limit of f of x as x approaches negative infinity, also known as the end behaviors, okay? Go ahead and pause here, really think about it. And then it's okay if we get different answers, all right? Because I think we learn more from a wrong answer than we do from a right answer, okay? So go ahead, pause there, press play whenever you're ready. Okay, so as x is approaching infinity, so as we go to the far right, okay, I notice that if I walk all the way to the right, forever and ever and ever, looks like the graph is going all the way down, far down. So far down is just negative infinity. Hopefully you guys got that one, okay? That's the easier one of the two. Now here, as x is approaching negative infinity, we're walking to the far left. So as I'm walking to the far left here, okay, what is it approaching? Okay, so here is one of those cases where you kind of have to analyze it. Notice how the blue curve gets really close to the x-axis, but it doesn't seem to cross it. Okay, so to say that the graph goes far down is probably not an accurate interpretation, okay? But also to say that it curves back up is probably not an accurate interpretation either. So what y value is it approaching? Okay? So when you get really close to the x-axis, what's the y value when you're on the x-axis? Just think about any point on the x-axis, right? What's the y value? Okay, so when you're getting really close to the x-axis, the limit actually comes out to 0. Okay, because it doesn't go far up or far down, it just gets really close to the number 0. Okay, even though it doesn't really get there, but that's a different conversation, okay? It's one of those rare cases that you got to watch out for. All right, okay, so where does this lead us? Okay, here's the last part for the lesson. Our job for this unit is to be able to sketch any type of higher order degree polynomial. So what I mean by that is you guys are used to graphing x or x squared. It's either a line or a parabola. Okay, but what happens when the degree gets larger, right? To the third power, to the fourth power, to the fifth power. Is there some pattern to it? Okay, so I want you to take a look. There is a pattern with odd degree functions. And there is a pattern with even degree. Make sure you guys write degree, okay? Functions. So I'm going to show you guys here through Desmos. Now, you can draw it out if you'd like. Or you can just watch and explore, okay? So what I'm going to do is I'm going to draw a bunch of odd degree functions, okay? So y equals x to the first. Now, I know I don't need to write to the first power, but it's just to show you guys, okay? Then I'm going to write y equals x to the third. Now, what you're looking for here is you're studying the end behavior, okay? Y equals 6x to the third. Y equals 4x to the fifth power. Y equals, let's do 0.2 x to the seventh power. Okay, y equals 0.01 x to the 13th power. Okay, so take a look at this graph now, you guys. Okay, pick any one of them. Take a look at all of their end behaviors. Okay, I'll take a screenshot of this real quick. Okay, so that's my Pokemon. Take a look here as I expand it. If you guys pick any graph, all right, any one of these graphs, so y equals x, x to the third, 6x to the third, 4x to the fifth, x to the seventh, x to the 13th, okay, you noticed, okay, pick any of those graphs, what is the limit? Let me see if I can write, okay. What is the limit of the function that you're thinking of, okay, as x approaches infinity? And what's the limit of f of x as x approaches negative infinity? Okay, whichever function you picked, answer this question here and then press play when you're ready, all right? Okay, so I'm going to tell you guys right now, if x is approaching to the far right, all of your answers should be far up, positive infinity. Okay? If you take a look here, no matter which function you guys pick, I'll use a different color. Notice how all of these graphs go all the way up. Okay? Now, if you go to the far left as x approaches negative infinity, notice how they all go down, far down to negative infinity. So there's a pattern here. All right? But here's what I want you guys to think about. I'm going to flip the script a little bit. What I'm going to do is I'm going to put a negative in the front of all of my functions here. Okay. So now, right, what changes? Okay, so what's the limit? What's the limit of f of x as x approaches infinity and negative infinity? Okay, so here we go. The limit of f of x here as x approaches infinity, if you go to the far right, what do we get? And if you go to the far left, as x approaches negative infinity, what do you get there? Pause and play whenever you're ready. Okay, if you go to the far right, you notice that they all go downwards to the far left, so that's negative infinity. And if you go to the far left, notice that they all go far up, positive infinity. And it makes sense because remember what this negative does to a graph when you guys are dealing with transformations, right? A negative makes it flip, right? Okay. Now, almost there. Now I'm going to take a look at all the even degrees. And that should be enough to tell you what's going to happen here, okay? So all the even degrees, so y equals x squared, y equals 5x to the fourth. I'm just making up anything here. Y equals 2x to the sixth plus 3x minus 4. Y equals 0.1 x to the 8 minus 4x squared plus 2x minus 4. Y equals x to the 10. Okay? So I gave you guys a bunch. Okay? So notice how, although all the functions are very different, what does that say about their end behavior, right? Okay, so let's examine that real quick. Okay, so notice how some of them go a little bit crazy, like that green function right there wiggles a lot, right? But remember, we don't care about what happens in between. We care about what happens at the end behavior. So here, the limit of f of x, regardless of whichever graph you guys pick here, when x is approaching infinity, when we walk all the way to the far right, you notice that the graph will go all the way up, far up, to infinity. Now, if we take the limit of f of x as x approaches negative infinity, so if we walk to the far left, notice how the graph still goes all the way far up. What do you guys notice about these two limits here with even degree functions, right? Think about that, pause there, and then we'll talk about it. So if you notice here, when we're dealing with an even degree function, the end behaviors are the same. Positive infinity, positive infinity. Now let's go back to odd degree functions. When you have odd degree functions, were they the same? No, they were actually one of each, right? They're always different. There was always a positive infinity and a negative infinity. Here it was odd as well, but we had a negative infinity and a positive infinity. So you guys are trying to pick up patterns here so that we can pretty much at the end graph anything that we want. All right. So we have a pattern here. Even degree functions tend to have the same end behavior. And we'll write that down later. Now, what would happen, lastly, if I put on negatives? Okay. And some of you might have asked earlier, what if they have all these extra terms like this green function right here that has a negative 4x squared plus 2x minus 4? You're only looking at the largest degree. Okay? Everything else below it really doesn't matter. So if you take a look at this graph here, even though all of them are reflected, notice how, we'll do this last one here. Notice how, even if we reflect it, the limit of any of these functions as x approaches infinity, when we go to the far right, it goes far down, no matter which function you guys pick, okay? And if we go to the far left, as x approaches negative infinity, they still go far down, okay? But notice how the limits or the end behaviors are the same, okay? So this is the start of how you guys are going to graph anything that you guys want, okay? So here we go. We go back to our chart. Even degree functions have the same end behavior. Go ahead and write that down. Even degree functions have the same end behavior. Okay, you guys notice that odd degree functions have different end behaviors. You have pretty much one of each. Okay, now what we do here is we pay attention to something called the leading coefficient. When you're in the lead, you're in the front. Okay, so the leading coefficient is pretty much the number that's in front of that largest degree term. So if we go back to all of our pictures here, like for that red function, the leading coefficient is 6. The blue function, the leading coefficient is 4. Okay, and so on. Now, here, even though we have a bunch of coefficients, the leading one for the blue function here is just a 2. It would not be the 3 or the negative 4. Okay? Notice that when we're dealing with even degree functions, when the leading coefficient was positive, both end behaviors went up. Okay, I'll say that again. When the leading coefficient for an even degree function was positive, both end behaviors went to positive infinity. Okay? Okay, so when the leading coefficient is positive, we'll say that both are positive infinity. So I'll just put far up. Okay? Now, if the leading coefficient is negative, they're still going to be the same end behavior, but they're both going to be, both are, so those are ditto marks, both are going far down. Okay? And that's basically it. So let's examine odd degree functions, and then we're all done for the day. So leading coefficient. So what happens when the leading coefficient is positive? And what happens when the leading coefficient is negative? Okay. So when the leading coefficient was positive, actually I'll use a picture for you guys. Notice how that when you go to the far right, it went far up. When you went far left, it was far down. Okay, when you went far right, it went far up. Far left, it goes far down. Okay, so as x goes to infinity, okay, so this is not exactly limit notation. It's just a different type of way of reading it. But again, get used to limit notation, okay? So as x goes to infinity, we notice that f of x went far up to infinity, okay? And as x goes to negative infinity, f of x goes to negative infinity, all right? So you would probably guess it, okay? But when the leading coefficient is negative, everything gets flipped. So as x approaches infinity, f of x actually approaches negative infinity. And as x goes to negative infinity, f of x goes to positive infinity. Okay, so here's where I'm going to leave you guys, okay? If I gave you guys something like this, f of x equals 4x, 4x to the 10th power plus 3x cubed minus 4x squared plus pi x minus 14.2. Okay? You may not know how to sketch this by hand, but you should know what the end behaviors are. Okay? So knowing that the leading coefficient is 4, which is positive, okay? And knowing that the degree is even, you should know what the end behaviors are. Okay? So are they going in different directions or the same direction, right? So let's look back. If you have an even degree, right? We said earlier that they end in the same end behavior. So they're either going to be both positive infinities or both negative infinities, right? But notice how the leading coefficient is positive. Okay, so the leading coefficient are positive. They're both far up. Okay. Now, if you guys are seeing this as a bunch of rules, the easiest thing to do, you guys, and I'll tell you guys exactly what I did when I was in high school too. You think of the two simplest functions that you deal with, right? Y equals x squared. If you know how these look, you should be able to answer every single question. So here is an even degree function that you guys know. Here's what's running through my head, and you guys will practice this, okay? I know my degree is even, so I'm not going to look at the line, okay? So I'm actually going to get rid of that. Okay? Now that it's even, and the leading coefficient is positive, I know it's going to be facing upwards. I know it's not going to look like a parabola, but it'll end like a parabola. So both end behaviors, so the limit of f of x as x approaches infinity should be far up. And as x approaches negative infinity, my handwriting gets better and better each time. Negative infinity, that should be also far up to positive infinity. Okay? Now, what if I put a negative in front of the 4, right? Well, then that means you're going to have a reflection. Okay? So this is the start of you guys understanding how a graph will look like at the ends. And then as we go on, you're going to learn, well, what happens in between? What parts or what components, what characteristics can we look at to kind of make the graph look a little bit better? Okay? So that's pretty much it, you guys. All right? So if you have a picture, it's easy to analyze. If you don't have a picture, get a picture. It's basically it. Okay? But please don't confuse far left and far right from far up and far down, okay? When x is approaching infinity, you're going to the far right. And then you're studying if it goes far up or far down. So if it's helpful to label it just like I have right here, if it's helpful to label, do it, okay? Not required, but if it helps you, please do it, okay? Practice, let me know how it goes, and we'll go from there.